So this question asks, identify whether each is a polynomial function and justify your answer. So a polynomial function is a function of the form f of x is equal to a sub n times x to the power of n plus a sub n minus 1 times x to the power of n minus 1 all the way to a sub 0 of x to the power of 0. So essentially what you have is your independent variable x that's being multiplied by another real number, and that x is also raised to a positive whole number. So if we look at 1a, p of x is equal to cos x, that doesn't look like the function that we've defined at the top. It's not a polynomial function, it's actually a trig function because you're taking the cosine of some angle x, right? You're not multiplying x by anything. So it's a trig function, it's not a polynomial function. We look at b. Yes, this is a polynomial function because you have x that's being multiplied to a number. In this case, it's -7. So this is a polynomial function. And then we have 1c, f of x is equal to 2 times x to the power of 4. This is also a polynomial function because you have a variable x that's being multiplied by a whole number 2, and x is also raised to a positive whole number, which is 4. We look at d. Yes, this is also a polynomial function because essentially you just have a bunch of terms that contain variables being multiplied to a whole number, and the variables also being raised to a whole number. However, if you look at the last constant term, you can think of it as x raised to the power of 0, because anything to the power of 0 is just 1, and 1 times 1 would simply just be 1. So d is also a polynomial function. And then e, k of x is equal to 8 to the power of x. This is not a polynomial function. This is actually an exponential function because here x is not being multiplied by 8. X is actually being raised to the power. So this is not a polynomial. And then here f, y equals x to the -3. That's also not a polynomial function because since the exponent is a negative number, you can actually rewrite it as 1 over x to the power of 3. So this is using the property of exponents, where you can rewrite a negative exponent as a positive exponent by taking the reciprocal of that number. So this will be called a rational function because you're not multiplying x by anything. You're actually doing 1 over x to the power of 3.